See, special. I'm going to share my screen. Oh, who's that? Who just came in so I can add you to the attendance quick before I get into class? Somebody yell out who it was, in case they can't hear me. Oh, goodness, that was more people.
It was Jessica and Mercedes.
Jessica
and Matthew.
And Matthew. So everybody but Ada. And there we go. So Jessica, Matthew, Sadie. All right. So this, let's scroll down. My computer's moving slow. This is where we left off. Look at all those notes we started with. Any questions about that assignment? Did anybody do it or did you forget about it because you were focused on the test? I'm not seeing any questions, so I'm gonna move on. Take this down. Yeah, I don't know how to move the stuff over, so I guess Ada's the only one not here. She can see it. But you know what, maybe if I make it presentable or whatever, that'll move things over. See? Yeah, I'll probably hide some stuff. Anyways, I don't know who is going to tell me when they're done. I'll just check in. Just going to read this out just in case for people looking on the recording. It says the rules of graphing are the same for equalities, and then in brackets it says y equals 3x plus 2, for example. Over here, after where necessary, it's comma, broken lines. Everything else should be visible, I think. When you're done, when you're done writing, can you put a thumbs up, please? Thank you, Nathan. Thank you, Evan, Aaliyah, Matthew, Kate, Ryan, Ben, Jessica. I think I just need Kayla, Sadie, and Brianna. Oh, got Sadie, Brianna. Kayla, you still writing? Oh, success. Sorry if I missed you, buddy. There we go. I think that's everybody. If not, make some noise. Next slide. Oh, sorry. I wanted to say something about that. I'm pretty sure. When it says intuition, what I mean by that is, if imagine this equation y equals 3x plus 2. If it said y is greater than 3x plus 2, then you have the kind of 3x plus 2 line, and then you just shade above that because y is greater than, so you shade above. If it was y is less than, then you shade below. So that's what that means. Is that Egg popping in, or did somebody leave? Find out in a bit. I'll explain the test point. I'll do the examples in a second. We just got one more page, I think, of notes. We got that on. Agda is here, just horribly, horrifically late. Shamefully, embarrassingly. I shouldn't say that. Maybe something's going on. It's lovely to have you, Ada, and everybody else.
Family.
I forgive you. Can't speak for the rest of the class, but I forgive you. It's nice having you here, Ada, because I don't have to try and keep track of thumbs up when people are done the notes. I just ask for you to tell me when you're done. Then I know everybody's done.
Did I just miss one page before this?
Yeah, yeah. It's one of those units where you probably, in all honesty, won't refer to your notes. This is one of those where it's kind of in the doing. It's not like steps that you have to remember or anything like that. It's just, you'll see. I'm gonna write down that y is greater than or equal to x squared minus 4, because I'll do that as an example. The textbook says, well, I should wait till Ada's done writing. I'll talk.
I'm done if you're waiting for me.
I am. All right, so what I was going to say is in the assignment for question number 3, it says do with a graphing calculator. I don't want you to do it with a graphing calculator. You can check your work with the graphing calculator once you've done it, but 3C would require a graphing calculator, so you don't have to do 3C. I think that's it for the notes. How do I get out of here? Don't take that down. That's not for you. Well, it is for you just tomorrow. Not tomorrow, Monday. Not Monday. Monday's a holiday. I won't see you guys again for a week. By the way, tomorrow at 11 a.m. is kind of open office hours for PreCal. I won't be here, there, available, but I can make time for you when you need. So just let me know. Anyways, examples page, no, examples page 277. All right, it's gonna let me keep sharing. No, it's not. All right, I'll do it in a second. New share. There we go. Okay, so this is the textbook. I'm just gonna move my window over. Let's look at these examples. I'm just gonna, so 3x minus 2y. I'm at home, in case you didn't figure that out, and I realized I don't have any graph paper here, so please forgive me. Now, this example at the bottom of the page says rewrite. I just wrote on myself. Rewrite the following inequality into slope-intercept form. We're going to do that, and we're going to graph it. So let me do this. Shoulder is twitching. Is this focused? Yeah, it is. All right. So this one we'll do later, but this is what we got right now. It's number 1, page 277. So first thing it wants us to do is put it into slope-intercept form. So kind of the y equals form. So I'm going to subtract 3x from both sides. So I got negative 2y less than or equal to negative 3x plus 6. Now I'm going to divide everything by negative 2. Remember, when you divide or multiply by a negative, this thing flips. So it's y is greater than or equal to 3 over 2x minus 6 divided by 2 is 3.
Could you slow down for 1 minute so I can write this down?
Yep. Anybody have questions how I did that? How we got there?
Okay.
Okay, so on our grid, now this is a greater than or equal to, so it can be a solid line. If it doesn't have that line underneath it, it would be a dotted line. So the y-intercept is negative 3. 1, 2, 3, so its intercepts there. It's a positive slope, a rise of 3 over a run of 2. So 1, 2, 3, 1, 2. And so that's all I need to draw this. Should always label these. I get lazy. It would be, like I said, a dotted line if it was not equal to. But this, you would use a ruler for. and a pencil, and you would go through both dots. Now this is y is greater than or equal to. Well, y gets more positive, gets greater as it goes up. So that means that this is the side that gets shaded. You don't have to do anything crazy with the shading, like that's plenty. Now I said, you use intuition to shade, which is kind of what I just did there, but you can also use a test point just to make sure. So let's take, for example, the point 0, 0. Unless this is going through the origin, 0, 0 is the easiest point to use, and I would recommend it. So when you punch 0 in for both values of x and y, does the equation make sense? It should make sense because that's the part that you're shading. So let's try it. So 3 times 0 minus 2 times 0, is that less than or equal to 6? Well, 0 minus 0, 0. Is 0 less than or equal to 6? Yes. That means we've shaded the right part of it. If this bad boy here was flipped, that means we would shade this part, and then the 0, 0 point would not work. Does that make sense? Any questions, problems? Am I going too fast? All right, what was the other question? Number 2, x minus y is greater than 4. X minus y is greater than 4. So for this one, again, we put it into slope-intercept form. So subtract x from both sides, negative y is greater than negative x plus 4. Divide everything by negative 1, or multiply everything by negative 1. Same idea. Basically, you just change the signs of everything. And you flip the inequality. Y is less than, not less than or equal to, so it's going to be a broken line. So this is a nice slope of 1. The y-intercept is negative 4. 1, 2, 3, 4. 1, 2, 3, 4. It's a slope of 1, so rise a 1, run a 1. So it'll go through here, 4 over 4. It's a broken line with a ruler. Just see how I caught that one. It's terrible. You should be ashamed of yourselves. Now, y is less than. So this is the side that gets shaded. We want to check with the 0, with the origin. If this was going through the origin, I wouldn't use it to check. I want it to be something a bit clearer. You can use any point you want. You could use 100 and 100. That'd be weird. So if we're going to use 0, so it's 0 minus 0. Is that greater than 4? 0 greater than 4? No, it's not greater than 4. And that's why we don't have that part shaded in. It doesn't work. This is misleading. I don't want you to think, oh, we did something wrong. No, like the fact that this doesn't work is good for us because that's not the part we shaded. That wasn't the part contained in there. Questions about that?
Would it still work if you put the zeros in like the equation that you had in slope intercept form?
Yes, yes. But the only reason that I would hesitate to do that is just in case I made a mistake getting to this, then I'm not testing it properly. Do you know what I mean? That's why I prefer to go into here. Because if this doesn't jive, then I know I've done something wrong, and then I have to recheck everything. But if I plug it into here, I might be hiding my own mistake, if that makes sense.
Yeah.
So yeah, if you've done it right, for sure, it'll work. In this case, it would be 0 is less than negative 4, which still doesn't work, and that's a good thing. Like over here, 0 is greater than negative 3. That's true, and that's what we want. One more example with this one, unless there's any other questions. All right. So y is greater than or equal to x squared minus 4. All right. So this is already in y-intercept, slope-intercept, not slope-intercept, but function form here, standard form. So we have x squared minus 4. Our y-intercept is negative 4. Now, as it turns out, luckily for us, this one is factorable. So this is the same as saying x minus 2 x plus 2. Well, our zeros are right there, which makes it really, really handy. 1, 2, 1, 2. That's all we need. We have these 3 points to do this. But if it's not factorable, then just pick a couple points. Just pick, like, so we do the y-intercept and then plug in, like, when x equals 1. When x equals 1, 1 squared minus 4 is negative 3. So at 1, it'll be negative 3, and at negative 1, it'll be negative 3. Put in 2, 2 squares 4, 4 minus 4 is 0. So we can do this with a solid line. It's trickier, obviously, with a parabola. I have enough trouble drawing parabola, straight lines. But make sure it's a broken line. One thing you can do as well, if you draw a pencil lightly, instead of doing the dash line, then you can just erase sections in it. Just make sure it's really clear. Oh boy, missed that. Nailed that, missed that. So that's why you use a pencil, because you can erase this and do it better. Anyways, the shading, y is greater than. So it's the top side of the parabola. If it was less than, it would be over here. If we use the point 0, 0, it should work. 0 greater than or equal to 0 minus 4. Well, yeah, that's true. 0 is greater than negative 4. So we shaded the right part of it.
So if it's less than and like the shading is on the outside of the parabola, you can just use any point because it wouldn't be 0, 0, right?
Well, you can use, in that case, like if this was flipped, so it's y is less than, and then if you use this, it won't work, and that affirms that you shaded the right side.
Okay.
But yeah, you can use any point. Like this goes down to negative 4. So let's say, just for funsies, let's use 0 and negative 5. So that shouldn't be, right? So that's there. It shouldn't work. So 0, that's the y value is negative 5, sorry. Negative 5 greater than or equal to 0 squared minus 4. Negative 5 greater than or equal to negative 4. That's not true. And that's a good, that affirms that we've shaded the right part. So you can use any point. My point is just with zeros, it clears out really nicely. But don't use the origin if you've got a line going through it, because that could be misleading. Any point will work. Other questions? So that's it for today. That's so weird. We don't even have math again until next Wednesday. Man, I was talking about recording those extra lessons. I haven't even started to do that yet. I'm swamped with grad, but anyways, I'll get to it. Any questions or anything? That's all I got, my friends. Hang around if you got questions or what have you, but I'm going to stop recording.